Welcome back to my channel, everyone. 3 tips here, and what I have is some scrap gold. I'm going to start off with some 14K white gold scraps, and I've got some yellow gold that I'm going to add to that, and we're going to call it 110 for 14K, 110 grams. Zero this out. I've got some 10K white gold. Let's add this to our container up here. It looks like we've got 22.6 grams of 10K. Here's a little bit of 18K white gold. Zero the scale. Add this in. And it looks like we've got 22.7 grams of 18K. I've calculated that I need 196.5 grams of sterling, and our estimated yield is going to be 90.5. So I've got some sterling sitting up here, 196.3. We'll take this out and quart this gold with this sterling silver. Now we'll get this out of this container and get it into a glass reactor. the vacuum switch that I use on my vacuum system. There's the number of it. And what I've done is I've opened it up and I've adjusted the screw to create a less of a vacuum that I normally use. And you'll see here I've got it set. It turns off at 4, and then it should start back about 1 or so inches. It'll cycle back and forth right there, so I can keep the vacuum low as I operate my apparatus in the fume hood. Now what we're going to do is add some hydrogen peroxide to this bubbler. Cut in a little bit of vacuum now. Pull a vacuum on the whole system. Here we go. Okay. Got a tight system. Got a vacuum flowing through the entire system now. I'm adding a couple of chunks of ice to my coolant reservoir. And now we'll add some tap water. Here we go, we're going to fire up the coolant flow. There we go. We're filling up the all-in condenser. The discharge of that goes over here through this tube and we'll fill the gram condenser. Filling up. Yeah, here it comes. Some water coming. And then this will discharge back down to the reservoir. I think what we'll do is just add 100 milliliters of nitric acid to kick the reaction off, just get it started. I'm going to turn the vacuum off. I'm going to remove the vacuum line from this flask up here. I had to disconnect the vacuum connection. I'm going to have to leave that off of there because the vacuum system is pulling all these nitrogen dioxide fumes, discharging them into my workspace. So the vacuum, that was a bad idea. That's not going to work. Measuring out 250 milliliters of distilled water. We're adding 250 milliliters of nitric acid. So the first part of the experiment was a fail. I was going to try to bubble all those nitric acid fumes out of here by bubbling it through the hydrogen peroxide, and that didn't work. So I'm adding the dilute nitric now into my funnel. I'm adding some heat over here, and we'll start dripping our dilute nitric acid down into our reaction. I stopped the flow of nitric down into the glass reactor. I notice that I'm getting some blow-by, some leakage of red fumes coming out of this thing here, and it's putting a lot of red fumes up in my catch container. So now we're going to have to see if we can get this thing to seal up. I don't know if this reaction will be able to continue or not. You can't let this stuff get out into the space. It's being drawn into the fume hood. But I don't know if I'm going to be able to continue like this. Might have to shut it down. I think I had some trash in here, and I've rinsed it all out with water. The fumes are flowing through the condenser, through this elbow, and down into my catch flask. Turn the heat on a little bit down here. And now we're going to go ahead and resume the acid flow. Keep a close eye on it and see what it's going to do. Everything seems to be going okay now. I've got this plug to seal up. But what I've discovered here is in this condenser that has the catch can on it, it's got gas traveling through that coil of glass in there. And what's going to happen is if anything does condense, it's going to form little bellies in these coils and plug up the flow. Right now I'm getting gas flow, as you can see it coming out of the exhaust there. But if anything does condense in here, it's going to plug up the glass tubing and then create a back pressure, and that's going to want to try to pop these seals on these plugs. I think what we're going to do is I'm going to have to reconfigure this. If I do crank the heat up, it's going to start boiling fairly vigorously here. It's going to put a bunch of pressure on the system, and then the tubing in there will get plugged up, create a back pressure, and these plugs will come loose out of this reactor. got it reconfigured. I'm going to start adding some heat. And I'm going to pull up my funnel and add some dilute nitric acid. I think this reaction is complete. I don't see any more fume production in there. I'm going to shut the heat off and let it cool down. Adding the next charge of 50/50 dilute nitric acid and add some heat. I think this reaction is done. Turn the heat off and let this cool down. I've allowed it to cool completely. What we'll do now is go ahead and recharge our addition funnel. Let's reinstall our plug. Start dripping some acid down into the gold. I can add it fairly quickly now because it's most of the silver's already been removed. We'll add some heat and let this react. Tell all the nitric acid has been consumed because of the lack of fume production in here. So we'll turn this off now and let this cool down. This has been allowed to cool. So now we're going to take everything apart and get the liquid out of here. Now we're going to get the liquid out of our flask. Rinsing the gold with some distilled water. And get this out of the way. I've got another empty silver jar here. And what we'll do is rinse this a couple more times with some distilled water. Here's a look at the gold so far. It looks really good. And so now what we'll do is I'm going to add about 100 milliliters of distilled water. Now we'll reassemble the apparatus. Measure out about 100 milliliters of nitric acid. And now what we'll do is add that right into the reaction vessel here. Turn some heat on and let this boil in that dilute nitric acid. While this is boiling, we're going to pull our solution back up here and take a look at this. What we're going to do is this is the copper that we pulled off, but you'll notice that it's green. And copper in solution is normally blue. So we're going to take a sample of this liquid. I'm going to drop a little bit more of this liquid and add it to our test beaker here. And now what we'll do is I've got some DMG dissolved in a little bit of water. DMG is dimethylglycine. And the reason we're going to test this solution with some DMG is because we had white gold in this batch of carrot scrap. And white gold is a known carrier of platinum group metals. So what I'm going to do is I'm going to draw some of this up. I'm going to add it to this solution. If there's any platinum group metals in there, especially palladium, then we'll get a yellow precipitate that forms in here. I'm going to put it on time lapse and add the DMG and see what we got. You can see here clearly that we have some precipitate in that solution from the DMG reacting with the platinum and palladium in that solution. So that confirms that we've got the platinum group metals in our solution, which is what I suspected because we had white gold in here. So this main solution in this flask right here, what we'll do is we'll filter that off, and I'll add some more DMG to it and extract all the platinum group metals with the DMG before I cement the silver out of that solution. Copper in solution is blue. Silver in solution is crystal clear and colorless like water. Platinum group metals in solution are yellow. So when you mix yellow with blue, you get green. Now we're going to show you what happens when we take the platinum group metals out. I've got a little filter set up here. I'm going to go ahead and filter out the DMG precipitate. And you'll see that our solution has turned blue now since we've removed all of the platinum group metals from it. We've got a pretty good separation here. We've separated the platinum and the palladium from our solution. That's it in the filter there, that DMG precipitate. And now we've got only silver left in this blue liquid down here. We'll cement that out with copper and run that through our silver cell. And then we'll take our big flask of green liquid that we pulled off of our reaction out of here and use DMG to pull all the platinum group metals out of that also after I run it through a filter. I've had this on boiling now for at least an hour. And I don't think we're going to get any more mileage out of the nitric in there. So we're going to go ahead and kill the power, let this cool down, and get in there and see what we got. Got a stubborn piece in here that doesn't want to come through the opening. So I'm going to smash this up a little bit with our glass rod and then get it out of there. All right, there we go. We got it all 100%. I'm going to put our gold up on this heating pad. Look at that, man. It looks beautiful already. Nice caramel brown color. And what we'll do is put some heat on this and give this a boil in some distilled water. All right, here's our gold. After we've removed all the silver and the base metals from it, it looks pretty good. Let's see if I can get this in here. There we go. Look at that stuff, man. Beautiful. This is about 3 true ounces of gold. So now we're going to add some hydrochloric acid. What I'll do is fill it up to about 400 milliliter level, I guess, with hydrochloric acid. Cover this up. I'm going to stick it back up here on our heating source. What we'll do now is go ahead and try to dissolve this gold. I'm adding a few milliliters, maybe half a milliliter actually, of sulfuric acid to take care of any lead that may be present. I'm going to measure out about 25 milliliters of nitric acid. Now what I'll do is I'll cover this up. Add the nitric acid in. Let's add some heat. We'll put this on time lapse and just let it react. Here we go. We're going to add the nitric in. just a few crumbs down at the bottom of this beaker. I'm going to pull this down off the heat, and we're going to let this thing cool down off the heat now. I've iced our solution. That'll cool it down, dilute it, and precipitate any silver chloride that may be present. What I need to do now is I've got my waste container here. It's full of waste, and I need to pour some of this off into another storage container that I like to use. In there. Probably ½ ounce in there. Here's what's left in our filter. Use some sodium metabisulfite to precipitate out pure gold. Here we go. Adding another spoon of SMB. Give this thing a stir. I think what we'll do to expedite things here is set this up on the burner give this a boil. See if we can get it to settle out right quick for us. That worked out fairly well for us. Let's go ahead and pour this waste solution off into our waste container. Okay, here's our pure gold. Looking real good. We're going to rinse it off a few times with some distilled water. Now I'm adding some hydrochloric acid. We're going to boil this in hydrochloric acid for a few minutes. I've had it boiling now for probably 20 minutes or so. And you can see there's a color to it. Someone asked if I'd do this. Reach in here and get a little bit of a solution on a piece of filter paper. Do a quick Stannis test. Hardly anything in solution. Maybe a little faint stain. Now what we're going to do is go ahead and pour this off into our waste container up here. Now I'll give it repeated rinses with some distilled water. I'm going to transfer the gold into this milk dish. We're going to take this over to the melt table and melt an ingot. Here's our pure gold bar. It looks excellent. And we were expecting, the expected yield on this was 90.5 grams of pure gold. So let's see what we got for an actual weight on this thing. 90.0. So we're off by what, half a gram? That's to be expected. All right, this was a monstrous try at using a new refining rig. It didn't work out like I had planned, but we still got the end result, which is this beautiful, beautiful bar of pure gold. This will conclude the video. I'd like to thank everyone for watching.